this is another place where students get tripped up a lot. So the word speed and the word velocity are very different in physics. Yes, we did mention that the velocity is sort of the vector version of the speed. But it's not quite true in some of the scenarios. Now, this is how we define the average speed. Yeah, let's focus on the average, speed and average velocity for now. Right? We'll get to the instantaneous speed and velocity in future lessons. So average speed is defined by the ratio of the distance traveled to the time taken. So I know that it's a weird letter here. So now, just so you know, this is a script L. Of course, I could have written the L like this, right? But that sometimes looks like a C. So it's conventional to write the L like that, so that our readers understand what it is. Now, delta L represents distance. You can compare that with delta X, as you remember that this is our notation for displacement. Okay? So we use distance to define average speed, and we use the displacement to define the average velocity. So now you can see that the only difference between the average velocity and the average speed is that the average velocity comes from displacement, which is a vector. The average speed comes from the distance, which is a scalar. So now the question is the displacement the vector version of the distance? Which is not quite. So this is how we define the distance. The distance is the length of the path moved by the object. All right, so now this is a diagram that I usually ask my student to keep in their notebook. It's probably one of the best diagrams out there for you to differentiate between distance and displacement, and later on you can use something like that to also remind you the difference between the speed and velocity. Well, average speed and average velocity. Here's the diagram. Right. So let's say we have a little bug that's crawling on the board here. So the bug starts from here. All right, so we're going to go through some crazy path and I get to the end point. Now, according to the definition, the length of the actual path, right, taken by this object is what we call the distance. Then what about the corresponding displacement for this process? I'm going to use a different color to draw a vector that starts from the starting point and ends at the end point. So this, bluish vector or arrow represents the displacement here. So now you're telling me the difference or differences between distance and displacement. I guess that you have a lot to say, right? But I just want to put the distance is the actual path of the movement, where the displacement only care about where the object starts and where it ends. So now a quick check. True or false? The magnitude of the displacement is always less than or equal to the corresponding distance. Let me repeat. The magnitude of a displacement is always less than or equal to the corresponding distance. And the answer is true. Right? You see that the magnitude of a displacement is just the straight line distance, right, between the end point and the starting point. But the displacement, but the distance is the actual path, right? So if the object were to move straight ahead from the start to the end, then of course, the displacement of the magnitude of the displacement must be the same as the distance, because it's the straight line distance, right? The object moves straight ahead. But if the object ever deviate from the straight line path, like you see here, it's taking some crazy path, right? You know that the straight line distance is the shortest between 2 points, right? So therefore, the distance, which is the actual path, right, the curly path here, must be greater. Or in other words, the magnitude of the displacement must be less than the corresponding distance, or in a very special scenario, when the movement is straight, right, from the start to the end point, then you get to have the magnitude of the displacement the same as the corresponding distance. Therefore, you cannot say that the displacement is just the vector version of a distance. They're very different, right? Completely two different things. So now, if I were to ask you, what is the difference between the average speed and average velocity? I wish you're going to tell me that it is exactly the same difference between the distance and the displacement. And now, whatever you can say about the difference between the distance and displacement can be based on this diagram. Keep that in your notebook.